during the project, or at least hardships that I went through, especially with the hand. We decided to use pneumatics for the hand, and well, that was kind of a pain, being that we didn't learn too much about pneumatics in the class. So we basically had to figure out how to make our own fingers, opposable fingers, and make them kind of bend at each individual joint. Not only making them bend at each joint, but making the joints themselves, and then figuring out how to fit it all onto a mount for the to put on the arm. And that was kind of a pain in the butt, especially figuring out the grip strength. The only problem with pneumatics is that they don't really have that much grip strength. So what we did is we actually decided to use air compressor tanks, put it on the back of the arm, or like around where the hand is, and that actually increased our grip strength a lot. Other things that we did to it were we added a lot of rubber bands. And that helped with the grip strength, that helped with creating tension that can wrap around the test tube. And yeah, some of the stuff that we did for that. I was also in charge of basically designing and kind of building and painting the helmet. That was quite a struggle, if I have to say myself. It really wasn't that hard to do, but it required a lot of time, labor, and it kind of became kind of like a crunch time kind of thing. And it was just kind of like layer after layer of paint, you know, cutting out each individual piece for the frame, the mold, and everything. It was really hard, and one of the hardest parts was actually the visor of the helmet. And because what we did for that is we had cardboard that was cut so it can make rotate kind of and make like a lens looking thing, and then we cover that in Bondo, or it's called autofilament. And we figured out autofilament stings a lot when it gets onto your hand, especially the drying agent that they use for it, and it also doesn't come off your hand. So it was a good 30 minutes to an hour where I just had this Bondo stuff covering my hands, and my hands just stung and hurt. And then not only that, but I had to sand the thing down after I put the Bondo on it, and that took another good 45 minutes out of the time where I could have been painting or could have been trimming the helmet, and it was really just a pain all the way through.
So for assembling the breadboard, we used 4 different LEDs. Red basically meant going forward, blue basically meant going backward, and yellow and green meant going right, and green meant going to the left. And push buttons, they were really hard because some of the push buttons, they were really old and they break most of it. So it was kind of difficult because Mr. Burns, he gave us new ones and they were like really big. So we had to attach with a jumper wire. Also the battery, some of the batteries were dead, and it was kind of like really difficult. And so we did 3 different setups. So the first part was like where it was designed, it was only one system, so it was providing the LED was on all the time, so that wasn't the problem because it was doing, the push button was doing the opposite job. The another part was either use the big breadboard, it was too difficult to fit in the helmet because the great advantage of using a big breadboard was that everything would be spread out, so that's why we used the little breadboard, so the LEDs would be on the other side. And another step was with the Hummingbird, so we used different sensor, light sensor, speaking, and turning and distance sensor. And basically it was really easy to connect the parts. We used Hummingbird kit and the tutorial, and we just attached it to the helmet, and yeah.
In designing the arm, we first started out very ambitiously, where we designed all the joints from the shoulder all the way down to the wrist. But that proved to be really difficult because there were a lot of motors that we had to use, and that would be a lot of programming to do. So we shortened it down to the elbow, where we had the elbow bending and then the wrist. And so that was a lot easier to do. And then with the controller, instead of using simple levers, we decided to use a joystick where when you move it forward, the arm would go down, move it back, the arm would go up, and then push buttons to control the wrist in order to make it the control as precise as possible. And then we also had it where if you twisted the controller, the base would twist with it. And then if you zeroed it out, the base would stop. So it allowed for really precise controls for us to complete all the missions that we had to do.
So programming the arm took a lot of trial and error. We started with something that would work, and then we kept perfecting it. So we just kept hashing out all of the bugs in the programming and just working on it until it was good. Once we changed the arm though, it took a little bit of a turnaround, and we switched from 2 NXTs to 1 NXT and a little bit of a simpler controller. So it made the programming a little bit easier, but we also went a little more sophisticated by programming the arm to move with the joystick and stop as the joystick was stopped. So that took a little bit more programming, and we had a couple thresholds to put in, but other than that, the programming was just a lot of starting with something and then fixing it.
So making the skin was really a trial and error process, so the whole thing was kind of hardships because we would make a sample initially, then kind of figure out, oh, this isn't elastic enough, or this is too oily, this isn't this isn't, it's too rigid. So each time we would make a sample, we would then look at, okay, what are the good things about it? What are the bad things about it? What can we change and alter slightly that should hopefully make it better? So in the end, we ended up having about 15 different samples. That was just a process of figuring out what ingredients worked best and what combination of ingredients worked best, so that we could have skin that was realistic looking, that was elastic, that wasn't too rigid, and just that would serve the purpose that we needed.